This is lesson 7 of CP1, which is unit 4. We're going to talk about parallelograms, angles, and sides. Let's talk. Looking at this is a whole lot of verbiage, and who really wants to read that, right? Nobody? Okay. Let's name some of the parallelograms. What's one of them? Starts with an SQ. Okay, starts with an RH. Rhombus. What's the other one? Rectangle. Rectangle, rhombus, square, right? Those are the parallelograms. And there are some parallelograms that are, well, none of those, right? A general parallelogram. A parallelogram that doesn't have 90-degree angles, and all four sides aren't the same. Right? So let's look at one down here. Let's talk about this opposite angles conjecture. In any parallelogram, whether it's general, square, rhombus, or rectangle, the opposite angles, guess what? They're congruent. Oh, fun. That's cool. Let me move away this secret, the door number 1, and show you the answer to that. Oh, they're congruent. Cool. All parallelograms, opposite angles are congruent. Is it possible that all 4 angles are congruent? Yeah, they'd all be 90. They'd either be a square or rectangle. Cool. Too easy. Okay, that is the opposite angles conjecture. What about consecutive angles conjecture? What would be true? We've already talked about this in a lesson past. What's true about, in this case, A and B? They're the first 2 letters of the alphabet. Yeah, you're right. What else is true about them? Yeah, Johnny? Yeah, there. What's the formal word for add up to 180? Supplementary. Yeah, good. So A and B add to 180. A and D add up to 180. B and C, they add up to 180. And C and D add up to 180 as well. So let's chat through an example here real quick. Do I have enough information to find all 4 angles in this parallelogram? Yeah. What would angle B's measure equal? Yeah, the same as the angle across from it. That'd be 110. And A and B I know have to add to 180. And A and C, well, they're congruent as well. Done. So a parallelogram is nice. A rectangle is even better when you're talking angles. It's fun. Square is best of both worlds. It's the golden child. All right, parallelogram, opposite sides conjecture. What's true about the opposite sides? They are congruent. Yes, the sides across from each other are congruent. Sides across from each other are congruent. Yeah, when we think of a square, we know that. Oh, yeah, duh. All 4 sides are the same as a square. Well, in a rectangle, it changes a little bit. Right? Might be just a taller version of the square or a wider version of the square where opposite sides are still congruent, but consecutive sides aren't the same. Okay. Let's talk about this one. Parallelogram diagonals conjecture. The diagonals of a parallelogram do what to each other? They cut each other in half. Yeah. What's the formal word for that? They guillotine each other. No. Is that a wrestling move? I think it is. Yeah. What do? They bicycle. Nope. Bisect each other. Yes, they bisect each other. Cool. Cut each other in half. Is that true in a square? Well, is a square a parallelogram? Yeah. Is it true in a rectangle? Yeah. How about a rhombus? Yeah. How about a kite? No. No, because it's not a parallelogram. Cool. All right, given this below, find A, B, and C. Somebody holler out an answer. Give me a letter and then a number. B118. Okay, I like it. Somebody else. Say again. What's 62? Did you just say I'm 62? You're 62, Mr. Ludd. Thanks. I'm actually 65. 62 for A. Okay. Since it's a parallelogram, that means C is also 62. Cool. I'm not offended, Lisa. It's okay. All right, let's see. These should be free chicken, you guys, on the test. Just like cash money in the bank. Okay, let's talk through a couple of attributes of this parallelogram because there's a lot going on, right? What do we know about sides across from each other? They're congruent. Oh, so W equals 5? 2 times 5 plus 2 is 12. 12, yeah. W equals 5, right? For those of you who weren't following me, could I say that 12 equals 2W plus 2? Yeah. So then 10 equals 2W. Yeah. So then 5 equals W. Yeah. Okay, so W equals 5. Somebody else tell me a number that they know and a letter that it goes with. Yeah, read. Z is 14. Good. How about Y? Spencer, the Blackhawks fan. Huh? Y is 8? Yes, I like it. And X has to be 9. Guys, you start seeing this stuff, and it just jumps off the page at you. All right. All right, let's see here. I got a couple of examples. Hey, with a neighbor, I want you to try this one. We'll come back together in 3 minutes. Okay, I'm back. Here we go. Okay, somebody tell me what angle B's measure is. 70, good. Opposite angles in a parallelogram are congruent. Now what? What's the next angle that you found, Johnny? Hey, what is it? Yeah. Not quite. A and this are 110. Which one's 60? C is 60, right? Because think about this. 70 and these two angles have to add to 180. So 70 and 50 is 120. That makes C equal 60. Now, is this proportional? No. You're like, what? That's such a fail, Mr. Ludd. Sorry, I'll donate $3,000 today to a charity of your choice. Okay, now what's true about these two angles? Well, they're alternate interior angles, so that's 60. So that makes A 50 degrees. Okay. So the diagram might not be perfect, but use the labeling in order to find the measures. This will probably happen a couple times throughout the semester and the year where you'll be like, the measure of that does not look larger than the measure of the one next to it. But trust the markings and work that way.